All right, in 5.2 part 3, we're just going to take a look at some story problems. So first idea is angles of elevation and depression. So an angle of elevation just means that we are looking up at something, and an angle of depression just means we are looking down at something. So in both of these cases, we really have to make sure that we're looking at the angle in the correct spot. The angle always is made with a horizontal line of sight, right? So, for example, right, if we look up at something, this is what the angle of elevation would be. But if we are looking down at something, the angle of depression is the angle that is created by looking straight out and then looking down. Okay, so in these story problems, we're going to have to draw pictures. So let's go through a few examples. The first one says, to determine the height of a cloud at night, a farmer shines a spotlight straight up to a spot on the cloud. The angle of elevation to this same spot on the cloud from a point located 150 feet horizontally from the spotlight is 68.2 degrees. Find the height. So for all of these problems, we are going to have to draw a triangle, right? So I already have some pre-made graphics here, but most of the time we're going to have to draw the triangles ourselves. So we know that these can all be modeled with right triangles. Now, it says that the farmer's here, right, shining a spotlight, then he walks 150 feet and shines the spotlight again to that same spot. And that angle that's created is 68.2 degrees. So here is the information that we have. With respect to this 68.2 degree angle, this would be the opposite side, this would be the hypotenuse, and this would be the adjacent side. So the trig function I want is tangent, because the unknown is opposite, the side that I do know is adjacent, so my setup would be tangent of the angle, 68.2 degrees, equals opposite over adjacent, so the height over 150. All I need to do is multiply that 150 over. And put that in the calculator. So again, remember, make sure that your calculator is in degree mode because we are dealing with our angles in degrees here. So I don't think the question specified what to round to. No, it did not. It just said find the height of the cloud. So let's round to 2 decimal places. So we would say our height is 375.03 feet. All right, let's try another one. Okay, this one is an angle of depression problem. So this problem is actually modeled by this picture right here. We've got a lifeguard sitting on a platform looking down at a swimmer in the water. The lifeguard's line of sight is 8 feet above the ground. So that means that this side of my right triangle is 8, and the angle of depression to the swimmer is 18 degrees. So this angle that's created here is 18 degrees. We want to figure out how far away the swimmer is from the lifeguard. So generally, okay, that statement is a little ambiguous, but generally, if we are talking about somebody moving on the ground, we would be looking for that distance, right? Even though technically the distance from the lifeguard to the swimmer would be this distance through the air here, the swimmer can only travel on the ground, right? The swimmer is not going to fly. If we were talking about maybe a bird, right, then we would want to look for this distance. Okay, so we just have to use context of the problem sometimes if they're not super specific. In this case, we would want to look for this value here. So I'll say that's my x. Now, the key with angle of depression problems is actually using a geometric idea. This angle here and this angle here are actually going to be exactly the same because they are alternate interior angles. right? If you remember that fact from geometry, the ground and this line of sight would be parallel lines. So if I cut them with a transversal, alternate interior angles are the same. So here is my right triangle, right? I'm dealing with respect to this angle, this is the opposite side, this is the adjacent side, and this would be the hypotenuse. So I'm dealing with opposite and adjacent, so my setup would be tangent of 18 degrees equals 8 over x. Then remember, for ones like this, where the variable is in the denominator, I would need to multiply the x over, divide by tangent of 18, and we'll get x equals 8 over the tangent of 18 degrees. And that we can put into the calculator. Right, and we get 24.6214. And again, I don't think this specified what to round to. So let's go to 2 decimal places. We'll say that that distance is 24.62 feet. All right. So let's take a look at a couple more that don't necessarily involve angle of elevation or depression. Okay, so on this one, to find the width of a river, a survey sights straight across the river from a point A on her side to a point B on the opposite side, then walks 200 feet upstream to point C, and figures out that the angle to that same point on the opposite side that she marked is 58 degrees. How wide is the river? Okay, so again, we want to draw a picture. We want to visualize this situation. I've got a pre-made visual here. Okay, so we're saying she starts here, marks a point B, walks 200 feet, and goes back to that same point, and this angle that's created is 58 degrees. I want to figure out how wide the river is. So, with respect to this angle, this is opposite, adjacent, and hypotenuse. So I'm dealing with opposite and adjacent yet again. So my setup would be tangent of 58 degrees equals the width of the river over 200. Multiply the 200 over. And that we can put into the calculator. Right, when we do that, we should get 320.07 if we go to 2 decimal places. All right, let's take a look at one more example here. This one is a little bit more involved. So this one says a surveyor wants to measure the height of Mount Kilimanjaro by using the known height of a nearby mountain. The nearby location has an altitude of 8,720 feet. The distance between that location and Mount Kilimanjaro's peak is 4.9941 miles. And the angle of elevation from the lower location is 23.75 degrees. We want to use this information to approximate the height of Mount Kilimanjaro. So, again, I've got a pre-made visual here, and this is a little slightly more involved than just drawing a triangle, right? But it still ends up, we're just going to solve parts of a right triangle. Okay, so here's my nearby mountain. Oops. All right, here's the peak of that nearby mountain. And we're saying that's 8,720 feet. And then we're saying that distance, right, from that peak to the peak of Mount Kilimanjaro is 4.9941 miles. Okay, it is important, right, that we're not saying that this is 4.9941 miles. Right, it says from peak to peak, and then the angle of elevation from this peak to this peak is 23.75 degrees. So, a couple of things that we need to do here. First, we have different units, right? This measure is in feet, this measure is in miles, so we need to convert. It does specify that our final answer should be in feet, so let's go ahead and convert this distance to feet, right? So we get that 4.9941 miles is 26,368.84 feet, 848 feet. Okay, so 26368 Okay, so now we can use some trick. So now, with respect to this angle, right, we're just dealing with this right triangle right here. So this would be the opposite side, this would be the adjacent side, and this would be the hypotenuse. So I'm dealing with opposite and hypotenuse. That's my unknown. This is my known. So I'm going to use sine in this case. So my setup will be sine of 23.75 degrees equals h over 26368.848. So then all I would need to do is multiply this over to get h by itself. And we can put that into the calculator. All right. So we get a height of that right triangle of 10,619.96625. Okay. So what that gets us is this piece right here. Okay. This piece right here. The entire height of the mountain is going to be that plus this 8,720. Right? To get the entire height of the mountain, I need to add those two pieces of information together. So if we do that, we get our final answer here of 19,339.96625. And again, I don't think it's specified what to round to. It just says find the approximate height. So if we go to two decimal places, we can say 19,339.97 feet for our final answer. Okay, so I've got a few problems of these for you to try. The final question is going to pop up asking you what questions you have.